Hello and welcome to another section in further maths. Today we'll be talking about ellipse, and in this section we'll be looking at this the concepts and the equations of ellipse. But before that, let us look at our previous lesson. Now, what is an ellipse? Welcome back. An ellipse is the locus of a point P. I showed us what the word locus means in our previous lesson when we talked about the parabola and the circle. Now, I said an ellipse is the locus of a point P moving in a plane such that the sum of its distance from two fixed points F1 and F2. Now we have a shape in front, right in front of us. Now this point is our point F2 and this point is our point F1. Now the point, they are called the foci, and they are all constant attached to them, and we take the distance from this point to any point on the vertex to be A and B. That are the distances. But remember, in our previous lesson, we stated the equations that can be used in calculating the vertices of an ellipse and also getting the figure for the foci. Now we have the co-vertices and the minor axis being a perpendicular line from the major axis and that of the focus itself. So let's go back into stating the formula that we stated in we stated before now that the equation of an ellipse is x squared all over a squared plus y squared all over b squared equals 1. This is when the ellipse passes through the origin. But when there is a value of x and y, then the equation of the ellipse becomes x minus x prime, where x prime happens to be the point the ellipse crosses the x-axis, over a square plus y minus y prime over b squared, which is equal to 1. Now this point, it has the x prime and the y prime happens to be the center of the ellipse. So the center x1 and y1 happens to be the midpoint of the ellipse. But this is true only when the value of a is greater than the value of b, we stated in our previous lesson, and the major axis will be on the x-axis because the value of a tallies with that of x in the vertices. So the major axis will be on the x-axis, that is on the horizontal point of the ellipse. Now if the major axis is on the y, maybe if it's an ellipse of this nature, an ellipse that goes this way, where the major axis is on the y-axis, this is the y-axis, this is the x-axis, then the equation then becomes x squared all over b squared. Now it's no longer a squared again, because now you know b as the midpoint has y as its vertex, so it's now b squared then plus y squared over a squared, which is equal to 1. And when it's not passing through, this is when it passes through the center of the axis. But if there's a value being attached to the x-axis and the y-axis, remember how we stated it before, x minus x prime over b square is no longer a square, plus y minus y prime over a squared equals to 1. At this point, the center of this ellipse is still in x1 and and y1. Now let's go back to the previous this, and I showed you the point what we call the x1 and the x2, which is this point happen to be the vertices on the ellipse, and these 2 points happens to be the 2 point x1 and y1. So with this, you know, at this point the major axis of this becomes, because value of b is greater than that of a, so the major axis is on the y axis. That is all for when it comes to explanation of the equation of an ellipse. Now let's use this same equation into solving 1 or 2 questions before we move further to other subtopic under ellipse. Now let's look for, I said find the foci and the 4 vertices, of the ellipse. And the ellipse, the equation for the ellipse is x squared over 9 plus y squared over 25 being equal to 1. Now if you have x squared over 9 plus y squared over 25 equals, let's compare it with our normal equation of an ellipse. Now we stated the equation of an ellipse here, and we also stated it before now, as x squared over a squared plus y squared over b squared equals 1. If you want to go by comparison, you discover that your value of a is equal to 9. Your a squared is equal to 9, so therefore a is equal to plus or minus 3. So a is equal to plus or minus 3. But in this context, we have it that it falls in this, because they say find the foci and this of the 4. This, when you have the value of x being greater, so the value of your b is now 9. That is 9 because it falls on the y-axis. So we now have 9 squared, which is b. The value of our b is plus or minus 3, and that of a is equal to, so a squared is 25, so the value of our a is equal to the square root plus or minus the square root of 25, which is plus or minus 5. This is the value of our a. But remember the relationship between a, b and c, because we have a point c, and I'm using the Pythagorean theorem, just like what we stated before now, that our a square is equal to b squared plus c squared. So our c squared will be equals, that's 5 squared minus 3 squared, which is equals 16, because from here we have our 5 squared here is 25 minus 9 and is 16, so the value of our c becomes the square root of 16, which is equals 4 plus or minus 4. So with this, now let's go into answering our question. The foci of this ellipse will be at the point, let's go back to our previous scene, where we have f, okay, yes, the foci, which is here, that's our f0 c point. That is the first foci, which is 0c, just like what we explained in our previous class. So which is equals to f1 0.4 and f2 0 minus 4, because they're both in the positive and the negative direction. Why the vertices would not be that of, that is ii, the vertices are VAO, which is equals V1. So the first point is 3 and 0, just on the x-axis. The second should be, remember I said if the first is plus, the second should assume the negative sign. So the second one should be V2, then minus 3 and 0. That's the second point, because they are equidistant. Why in that of the x-axis, why in that of the b vertex, you know, we had 3 and 5. So that of the v, that is v b0, will now be v3, which is in bracket 0 and 5, Remember the value we got here, 3 and 5, has been the value of our A and B. So if V3 is 0 and 5, so the next one will now be 0 and minus 5, because the distance from each vertices to the center of the ellipse is usually equal. So the 4 vertices are V1, that's 3, 0, minus 3 and 0. V3 is 0 and 5, then 0 and minus 5. So in order for you to refresh your memory on what we've just discussed, I would like you to take the test that will be coming up very soon right in front of you, but always do well to use the lesson notes on the platform for better information on the topic we've discussed. Thank you. See you in our next lesson.